Welcome back everyone to West Explains Best. Today we're going to be doing factor quadratics by grouping in our Khan Academy tutorial. This exercise is talking about factoring different quadratics, mostly with a leading term, a leading coefficient, greater than 1. So here we have x squared. Usually we like factoring when it's just x squared by itself, but we have to get comfortable with factoring with a term in front of it. So here we have 2x squared plus 7x plus 3. And we need to factor this. What I always do first is I set up my parentheses. Now I do this in a kind of, I'm not exactly going to go by the book with this by grouping. I'm going to show you the way I like to do it. And I think doing it this way is in general faster, because if you get to a really complicated one, regardless if you use grouping or some other method, it's probably the fastest way might be just using the quadratic formula. So in my opinion, if you can't use the method I'm going to, you're better off just using quadratic formula or some other way to do it, okay? So this is kind of like it's almost like a puzzle. You just need to figure out where the puzzle pieces fit, and then you go, okay? So for the last term, we know the products are going to be from the second slot in both parentheses, and for the first term in the trinomial right here, we know that the first slot, the first terms in the first parentheses, or the first term in both parentheses are going to multiply to give you the first term. So I have that squiggly line here, and I think to myself, what times what gives me 2x squared? What are my factors of 2x squared? So they have to be 2x and x, or 1x. 2x and 1x. There has to be. There's no other combination that will give you 2x squared. So what I like to do, I just write 2x and x. Now, since I chose to put the 2x in the first parenthesis, that will affect it. Normally it doesn't matter with x and x when it's just x squared, but when there's a 2x, it does affect these. It does matter where you put these. Now I put in the first one, so that's just going to affect where we put the factors of the last term. So let me explain. Now we need to think of factors of 3. Now, normally we say, oh, what factors of 3 add up to give me my middle coefficient? But now we have a 7, and we know that factors of 3, 3 and 1, don't add up to 7. That's because you're getting help from this 2 here. This 2 is going to help multiply together to give you that middle coefficient. It's not pretty. So what I like to do is I put 3 and 1. 3 times 1 gives me those factors. Now I need to know, okay, I have 2 different combinations here. I can put the 1 here and the 3 here, or I could put the 3 here and the 1 there. And this is where the more you do this, the more you'll have some experience and where each one of those terms goes. So let's try putting the 3 here first. I'm going to use purple just to see that it's a trial. I'm going to put the 3 and the 1 there. Let's see how this works. Now, anytime you put some number in this slot, let me make it positive, in this outside slot, you know when you FOIL to get the middle term, it's essentially the inside and the outside term. So you know you're going to be altering this one, modifying this one with the 2x to get 2x. 1 times 2x is 2x. And then you have 3 times x gives me 3x. And these two terms need to add up to give you your middle term. In this case, we have 3x plus 2x. That equals 5x, which is not equal to 7x. So that is not correct. We chose incorrectly where to put the 3 and the 1. So what we're going to do now is we're going to switch them. So instead of the 3 here and the 1 here, we can put the 3 here and the 1 there. Now, if you wanted to, you could have switched to x and 2x. I like to keep these guys pretty much solid, and then I move around the other pieces. Now, there occasionally, if there's more than just one factor, you do need to move around these two terms, but I like to keep those set, and I like moving around these constants. It's just my personal preference. I think it's a little easier that way. So now we're going to check to see if this works by multiplying the outside terms. We get 2x times 1, we get 2x. Then we do 3 times x, that gives us, no, that's what we just had, isn't it? Sorry, I meant 3 and 1. Okay, now we do 3 times 2, it gives us 6x, and then we have 1 times x, that gives me 1x. What do you know? 1x plus 6x equals 7x. So our final answer is going to be 2x plus 1 times x plus 3. 2x plus 1 times x plus 3.